You are welcome to Physics Solution Center. For many years now that I have been teaching Cambridge A levels, there are questions that I notice smart students sometimes they miss it. And today I want to solve two key questions that are repeating themselves in current papers and some students miss it. This session is to help every student who want to get it right, especially when it has to do with vector resolution. Sit tight as I take you through the two questions. Let's start with question number one. The introductory part, which is the A part, says mass, length, and time are all SI-based quantities. Say two other SI-based quantities. In our previous video, I did SI-based units and dimension. So you can check the 7 SI-based quantities in the previous video. So we have mass, length, time. Here you can add electric current, absolute temperature. Question number B, the vector in particular. A wire hangs between two fixed points as shown in figure 1.1. A child's swing is made by connecting a car tire to the wire using a rope and a hook. The system is in equilibrium with the wire hanging at an angle of 17 degrees to the horizontal. The tension in the wire is 150 Newton. Assume that the rope and hook have negligible weight. Determine the weight of the wire. This is a question that has to do with coplanar forces. In coplanar forces, there is something that you should always remember, that when a body is in equilibrium, the upward force will be equal to the downward force. Just like your normal resolution. And this is where students miss. At this point, you need to know the angle to the horizontal. Here is 17. That means here will be 17 as well. Here is 17. Here will be 17. Remember, we said the sum of upward force equal to the sum of downward force. For us to find the weight of the tire, write sum of upward force equal to sum of downward force. For the sum of upward force, that will be 150 sine 17. That is for the first side, plus 150 sine 17 equal to downward force, which is the weight. And this will give us 2 times 150 sine 17 equal to W. W equal to 87.7 Newton. Can you see sum of upward force equal to sum of downward force? And you resolve it. Another way of doing it, you can resolve it. This is the weight moving down. You resolve this one in this way. So this is 17. This is 150 Newton. And this way, this is also the 17. Total here will be 34. Use cosine rule to get it. So these are the two ways you can do it, and students most times miss it. That is why I decide to bring this up. This is 2018 paper 2-3 October-November series. In recent papers, they are in objective as well. Your paper 1, check to ensure that you get it. If you see any of them and you are struggling to do it, kindly drop it in the comment section. When I'm solving other questions, I will attend to you. Let's look at the second one. I extracted this paper from October-November 2010, paper 2. This question happened to be pretty technical. If you are not very careful, you will definitely miss it. Before you look at my solution I'm going to solve, can you give a try? A block of wood of weight 25 Newton is held stationary on a slope by means of a string as shown in figure 1.1. The tension in the string is T and the slope pushes on the block with a force R that is normal to the slope. Either by scale drawing on figure 1.1 or by calculation, determine the tension T in the string. This is 3 marks. The 3 marks is not just the solving, it's also how you resolve it, vector resolution. What you should know is that this is 90. That tells you that the sum of upward force there is equal to the sum of downward force. We can resolve it. Look at what I'm going to do. Let's rearrange it. If this is at 90 degree, so we can rearrange it to look like this, and the resultant will be the hypotenuse. The resultant will be the hypotenuse. This is where so many students miss. The angle 35 will be here. Once you resolve it, you are good to go. Let's look at it. From SOHCAHTOA, sin theta equal to opposite over hypotenuse. Sin 35 equal to t over 25. T equal to 25 sin 35. And that will give us 14.3 Newton. That is the answer. So what makes it 3 marks? The ability for you to interpret, to get this vector, substitute, and get the final mark. So many students struggle with it from different feedbacks. That is why I decided to do this. We have so many other questions we are solving. If you have any question, you can drop it in the comment section. During one of my videos, I will do it for you. Here, our goal is to ensure that you get the best grades. So make sure you watch other videos, subscribe, tell your friends to subscribe, and see you in our next video.